Right, hello my lovely humans. What we are doing today is question 8 from the 2023 paper, which is projectiles, and then it gets into a bit of vectors. Now, the reason I'm doing projectiles again is I don't think that they know how to do vectors exam questions yet. They haven't figured out how to make it actually relevant, and they just seem to tack it on to something or ask you to calculate stuff and then get the dot product and then get the angle, and then that's all they know how to do yet. But I reckon something's got to come up soon, if not this year, next year, around working with the dot product to help solve something or to model something. So we'll get through the projectiles and then we will talk about the vector stuff that's necessary. So this question here is two things being thrown, one with 38 and angle 41, one with U and angle 64. One is a time equals 1. Okay, so there's a time shift as well. So this pretty much everything that is complicated in projectiles is happening here. And then they collide when t equals 3. So firstly, I have no clue what to do with P and Q colliding. But I know I can't do anything about that until I've kind of written down, constructed the I's and J's for the particles P and Q. Now I'm going to try to do that in a table, just typing, so it's not as messy, and you can pause it and look at it and make sure you're happy with what's going on. But what I haven't done here is I haven't prepped this question, because I want to go through the question and I don't know what the answer is. And if I make a mistake, hopefully you'll spot the mistake. But if I don't spot it and I do make a mistake, I then want to look back at the marking scheme and see what I would have got, despite the fact that I get it wrong. If I don't make a mistake, then great. But if I do, that's okay. And I just want to go through the marking scheme to see where we're at. So that, when you come out of the exam, and if it turns out you've made a mistake, you can still be confident that you got 27 out of 30 or 15 out of 20 or whatever it is. Because the answer isn't the be all and end all, even though it feels like it in applied maths. So what do we got? So P, okay, which one do we do first? P, I think we do first, because P is projected from point A at time t equals 0. Cool. So what I'm going to do is I'm just going to mark the arrows on this diagram here, where we have, this is 38 sine 41, and this is 38 cos 41. Actually, while I'm here, I'll do this one over at B. So this is U sine 64, and this is U cos 64. Now, when we are looking at two things flying, we have to be careful about the situation. Like, if they're both going in the same direction, the signs are obviously the same the whole time. If they're going in opposite directions, we may need to put the signs negative, or we can leave them as positive and then do something. Usually it is, say, the distance d here. I'll just have the distance d here. When they collide, this thing has traveled an amount to here, and this Q has traveled an amount to there, and where they meet, between them, they will have done distance d. So we don't need to worry about the signs, because we're just adding the two distances together to get a total distance d. I'm not sure how we're going to need that or where we're going to need it. I do know we are going to need it, but I'm not sure when we're going to use it. So, but again, all these things are not to be worried about until we have actually broken down the problem into lefts, rights, and up downs. So let's look at, so what will we do first now? Normally I would do, we'll try doing 4 columns and see how messy it looks. So we have, so we're going to do I's, and I need to zoom in a bit more. We're going to do math mode vec. Once the table's up and running, it'll be fine. J, I, J. I'll turn this into math mode in a second. Okay. So J vec Again, your teacher may do X, Y. I know I can blur my language a little too much, I'd imagine. So what we're going to do is we're going to have this one for particle P, proper pen, this one for this I and J for P, and this I and J for Q. I think this is the way that maybe makes most sense to break it down. So for P, we have U, and see this in the UX, even though it's the I thing. Anyway, for P and Q, UX equals 38 cos 41. The acceleration in the X direction is 0, which means the Vx equals, it's always going to be 38 cos 41. And then Sx equals ut, because there's no acceleration, it's our ut plus a half at squared formula. So it's 38 cos 41 t. And that's everything for particle P in the X direction, in the I direction, whichever you want. Now we're going to look at uv equals 38 sine 41. uv, y. ay is minus g, or minus 9.8, depending on what you want to. If we want to get a number, we're going to use 9.8. If we're happy with leave g there till the very end, we can leave it as g. Then this means vy equals v equals u plus at. So v equals 38 sine 41 plus or minus gt. Again, I be lazy and leave it as g for now. And then sy is 38 sine 41 t minus a half gt squared. So I prefer to write g over 2 because it saves me a tiny amount of writing. And so that's everything for P. UV, UAV, S, and T is built in there. And so now we do the same thing. You can pause it just to make sure you're happy with my numbers and work through your own diagram to make sure. Then for this one, for Q, Ux equals U cos 64. Now I'm not working out the cos 64 and the sine 64 and the 41s because it's going to be an annoying number, so we'll leave it till the very end, just so I don't make approximations too early and have to write down too much. Because again, writing down as little as possible is the best way to, or doing as little work as possible, the minimum amount of work to get the question perfectly right. Sx equals u cos 64 t. And again, there's no acceleration in the x direction, so that's perfect. And then we have let's see, y equals u sine 64. Back we go. Ay equals minus g. Vy equals u plus at, so u sine 64 minus gt. And then sy equals u sine 64 t minus g over 2 t squared. Right. that is the problem broken down into x's and y's, except there's one issue that I forgot or didn't deal with, was this is true if everything happens at the same time. However, we're told that Q is projected from point B at time t equals 1. How do we deal with that? How do we shift that? Now, we can do it manually and just kind of work through what we have to do and shift our equations by 1 second and put that in. But actually, if we want to work with the same t, it's a very easy fix for this, is that Q happens 1 second later. So when time is 1 is when Q starts. So what we need to go do here with Q is wherever we see t, replace that with -1. And I'm going to explain why that is in a second. It's a hard one to get your head around, but we know that when we know Q is thrown at time equals 1, so the distance Q is traveled from B here, over here, is 0 when time is 1. So if we put t equals 1 into this, we get 0, and it's the only way we can get 0, because we know cos 64 is not 0 and u is not 0. So how do we make the distance x 0 at time equals 1? And it is by shifting our time back 1 second. And we did exactly the same thing here. Wherever we see our t, change it to t minus 1, so that when t is equal to 1, that's when we will see Q starting its journey with the required numbers. So the thing that starts later is the thing that is shifted backwards in time. So now there's a lot there. So just pause, make sure you're happy, and just wait so that you're happy that the P numbers are correct. And then that the Q numbers equations are correct. And it's from here, like this, I suppose this is the same every single time. It's been a bit more work because there's two things and there's a time shift, but it's the same every time. So what we need to figure out now is, okay, how do we use that P and Q collide in midair when t equals 3? So what does that mean? If they collide in midair when t equals 3, what does that mean? Let's get one note to stop being annoying. What does this thing do? Okay, so what does that mean? So they collide in midair when t equals 3. So when t equals 3, if they collide, they are at the same point in space, or same position would even be better. They're at the same, let's say, point in space or position. So what does that mean? It means their heights are the same if they're colliding. So this means that the height of P, so this means that this 38 sine 41 has to be equal to this u sine 64 thing. So this means when t equals 3. So I'll just say i.e. the SYs what are you doing? Well, no, you're giving everything, making everything's head. The SYs are the same. So if they collide, it's when they end up occupying the same points in space and time. So at t equals 3, we're told they collide, so the heights have to be the same. Now, this might be enough, and I think it is going to be enough to get it to find this u, but the other thing it implies is that, and this is the thing I think we're going to use in part 2, is the SX, so the horizontal distances that P and Q have traveled sum to D. So what does that mean? So if they collide, it means, I will use the diagram here. If they collide, it means that this thing is, P has gone to say there, and Q has gone to there. Okay, so they are colliding. So the first thing we did was the SYs are the same. So they have the same height. That's kind of, I hope that's intuitive. What's happened next though is the horizontal distance P has traveled is that. And the horizontal distance Q has traveled is that. So between the distance P has traveled and Q has traveled adds up exactly to the distance between them from when they started. If Q has traveled halfway there, it means P has had to travel the other half. If P has traveled 1/5, it means Q has traveled 4/5. If it's a third, it's 2/3. If one has traveled 60% of the way, the other's traveled 40% of the way. So between the two of them, the two horizontal distances have to add up exactly to the distance they were apart at the start, that D. And we don't have a number for that, so I reckon we can't use that right now. But what this means is that I will zoom back in a second. So we know that that thing, which is our distance that P has traveled, that's the y direction, sorry. This thing, the distance P has traveled horizontally, plus that thing equals D when t equals 3. So here's what's happening. So we have two equations. I'll just highlight one of them in yellow, so that we have our vertical one where we know they have to be the same height above the ground. And then we have our horizontal one where we know they have to have, between them, traveled the entire distance from A to B. Now, you'll never know, I suppose, maybe you will know, but until you've read the question, you won't know which one you're going to need to be able to do. So it's important to know why each one is true if they are colliding. So if we put t equals 3 in the horizontal one, the pink one, we're still left with u and d. So that's two things we don't know. I think let's hope, therefore, that the yellow one is correct. So let's have a look and see what to do. So I'm just going to copy the text here. So what we're going to write down is this, except we're going to replace the t with 3, because we know the whole point is that we're told they collide when t equals 3. So that would be then, get a trusty calculator, 38 times 3. So that's 114. Now I'm going to do it in a bit more gory detail, just so you can be totally happy that that what I'm doing makes sense. So 3 squared is 9, so that's 9 3 over 2 equals 2u sine 64 minus 3 minus 1 is 2 squared is 4 over 2 is minus 2g. So that's just getting rid of the brackets and multiplying out the easy stuff. Now we're going to look at 114 sine 41 is 7.2166. I have no idea how many decimal points we're going to need. I know it says to the nearest whole number, but if this thing gets multiplied by 10 or divided by something, it's going to change. So 4 is usually plenty. So 9 by 9.8 divided by 2 is 44.1. Then sine 64 by 2 is 1.79758 u minus 19.6 is 2g. Okay, so let's just throw all the non-u parts over to the left. So that gives us 7.2166 minus 44.1 plus 19.6, and I seem to have made a mistake. Excellent. What have I done wrong? Because I'm getting a negative number, and I shouldn't be getting a negative number, I think. Well, as you know, I should be getting 28, and I'm getting something ridiculous. So what have I done wrong? Am I in degrees? Wait a minute, that sine 114 times sine 41 is 7. How did I get 7.2166? Okay, so if I had not known that u is 28, or I would have got this wrong. So this is 74.79. Very strange how I got that completely wrong. So 74, not 774. The reason I could spot the mistake was that sine 41 I know is close to sine 45, which is 1 over root 2, which is dividing by or multiplying by 0.7. So I knew it should have been a good chunk of 114, not a tenth of it. So 74.79 minus 44.1 plus 19.6 is, and I think this is getting us the right answer, 50.29 equals 17976u, which means that u is 50.29 divided by 1.797, which is 27.9. What's going on with the first key? 27.9 equals u. The reason I did 0.9 there only was that the answer is to the nearest whole number. So then u equals 28 meters per second. Okay, and that is correct. And I fixed one mistake as I was going. No idea what I did to get that thing wrong. If anyone spots what I did, let me know. So that's our u. So we've got that first thing correct. Now, where are we at? So that's part 1. I'm just going to scroll over here to get our part 2. Calculate d, which is, I suppose, the only thing that makes sense that they could have asked. Because we've we have that, we now know stuff about u. We can look at that pink equation and get d, I imagine. The idea is there's two properties for when they collide. One is the horizontal, one's the vertical. We have used the vertical, the yellow one, to find out something. So we've found out u using the vertical property. Now we'll put that u back in when t equals 3 and find the what the horizontal thing tells us. So this means that d, hopefully that sentence just trailed off, but we will use what we found out from the vertical to get something else from the horizontal thing that we know to be true. So 38 by cos 41 by 3 plus, now u is 28, so 28 cos 64 by t minus 1. Okay, and that's equal to d. I just reversed the equation just to make it easy. I'm just going to remember this thing went to here. Okay. So that means that d equals, now let's cos 41, let's hopefully get this right, is 0.7547. I think I just didn't multiply it by 114. Anyway, sorry. Plus 28 by 2, which is 56, times cos of 64 is 0.438. 0.4384. So multiply that by 56 plus 114 by 0.7547 gives you d equals 110.58. Now it doesn't say calculating d to the nearest whole number, so I would just leave it like that. I reckon if you put that in as 111, you'd get full marks because they've implied that they care about the nearest whole number. So I reckon you're going to get a good chunk of marks for that first bit because that's the setup of the question, and then D is maybe 5 marks. I hope, because it's very easy. Maybe, oh no, actually for your sake, let's hope it's more. So then, okay, so we've got vector language coming on, so let's see what they say here. In terms of I and j, calculate Vp and Vq, the velocity of Q when velocity of P and velocity of Q when the balls collide, i.e. when t equals 3. So what I would recommend here is I would write down, Vp, I would write down that and just get from our table at the very start what that's going to be, and write it down with t in there, and then also when the q one with u in there, and then put the numbers in. Just write them down so you have it down in the correct format. So for p, it's 38 cos 41 I, so 38 cos 41 I plus 38 sine 41 minus gt j. Okay, plus 38 sine 41 minus gt j. So I would just write that down, just so that you have exactly the correct thing that you want to work with down first before you start changing it, just preventing mistakes before they happen. And this one is Vx is u cos 64. So u cos 64 I. Now I know we know what u is and we know what t is, but we're just writing it down just to make sure we get full marks for this thing. It's an extra probably 10 seconds to write it all down first. U sine 64 minus gt j vec. And is that correct? T minus 1, not t. Oh. See, I even tried to do it right and I still made a mistake. So that's our VP and VQ in general terms, just for whatever u is before we figured it out, and for whatever t is. But we know u is 28 and we know t is 3. So this one implied, that means that equals to 38 cos 41. 38 times cos 41 is 28.679 I. Now I don't see any sensible nicer way of writing this down. And then that's 38 by sine 41 minus 9.8 by 3. And that gives us minus 4.470 J. So the reason I've done the 40 there, 470 is that if you do this, you'll see that the calculator will give us 4.4697, but the 697 rounds up to 47. But to show that we rounded to 3 decimal places, you need to put that final 0 in. So that's 28.679 I minus 4.470 J. And I just wrote that down just to give myself a little bit of a break before I started this one. Now I think I could handle kind of doing that t in one go on the VP, because there was only t we needed to change, but there's t's, there's a -1, and there's u. So I'm actually going to write down, I'll add up to t minus 1, but I'm just going to write down the rest of it in a bit of gory detail. So that's 28 cos 64 I plus 28 sine 64 minus t minus 1 is 3, so minus 2g, so that's 19.6, 9.8 by 2, j vec. Okay, so that's the first step of making sure I get this stuff right. And so I think this will be the last step here. We'll have VQ is 28 times cos 64, so 28 times cos 64 is 12.274 I. Now if we're in meters per second and we go to 3 decimal places, that's to accuracy to within the millimeter, which is pretty good. So 3 decimal places, I think, was it NASA do, when they do their calculations for landing probes on planets, they use 8 decimal points or something. So you know, it's interesting. Now I want to check that because I've got an answer. I think I may have got typed wrong. So sine 64 by 28 minus 19.6 is plus 5.566 J. And that is meters per second, and that is also meters per second. Okay, so that's our answer for our VP and VQ when they collide. So I think what's happening that they want it in terms of I and J, so they're going to ask us something to do with vectors here. So we've done all the hard work, all the fancy maths. We then just have to show that we understand how to work with some vector maths. So let's pull that question in. Again, just stop it if you need time to breathe and make sure what I've done is you're happy with what I've done. So that's part 3 is done. That's part 4 now. So part 4. Where are we at? 36. So when calculate the dot product. So the dot product, there's 2 formats for this thing, and we will need to know both of them, and because both of them are necessary to solve the whole thing, we will be able to find one of them directly with what we have and get an actual number, and from that other one we will then be able to figure out something about the vectors using the other format. So just the dot product, 2 ways of writing it. So it's VP one wrong key and everything goes mental. Now does dot work? It does. Nope. Don't know why it's up there. We'll just put a let's just do that. V okay, so okay, we'll just leave the dot there just because that's what Microsoft is giving us. I'll figure that out. Oh, that's what's happened. VP and V. What is going on? Sorry about this. V. Okay, no idea what's going on with the matplotlib there. So let's try again. VP vec. I'll put a dot in a second. Dot VQ vec. So I'll just put a dot there. So VP.VQ is gotten by multiplying the I by the I and the J by the J. So I'll just write it out here. So it's 28.679 times 12.274. So the I's by the I's plus the J's by the J's. So minus 4.470 by 5.566. Why I use brackets and times notation there, I don't know. So what that means is that we can get an answer for the dot product that way. Oh my God, OneNote is really testing today. So that's the I's by the I's plus the J's by the J's. So that's one way. So the I's by the I's and the J's by the J's plus rather plus the J's by the J's. So that's one way of getting the dot product, and we're going to need to know both ways. So that's one way, and we're going to get an answer for that in a second, but I'm going to write the other way down now as well. And the other way is, this is the one we're going to have to be careful on. another way is the dot product is the modulus of one of the vectors times the modulus of the other times the cosine of the angle between them. And that, I reckon, is what we're going to be asked to find in the next part, because we know everything about the dot product for this one, we can just get an answer. But let's have a look. What in this question, what's going on? Let's figure out what VP looks like. So VP is going across. It's going across and down. 28 across and 4 down. So roughly it's something like that. Remembering a vector is something that has distance and or direction and magnitude, hence the angle and the size of the arrow. And then VQ is going this way. Remember, the Q was fired in the opposite direction, so it's going up and across, so it's going across 12 and up. Whoops, why did it decide to do that? It's going across with 12 and up with 5. So it's going to be something like this. Now that's going to be something like that, maybe. I'll just exaggerate it, so that's VQ. So when two vectors crash into each other, this isn't as obvious as it should be, because the angles are fairly similar. That's where they hit. This angle here is theta. So the angle that the two vectors make, and it's usually the angle that's less than 180, is the angle the two vectors make with each other. So all that remains then is, for part 5, I imagine, is going to be modulus of P or VP modulus of VQ, which is just Pythagoras, and then put them equal and get cos theta, I imagine, but we're not there yet. But but we are here. Again, I'm intentionally not stopping to give you time to think, so that you can pause it yourself, and I'm not wasting anyone else's time, or your time, or my time with the recording. So this means that VP.VQ equals, and I'm just going to calculator this, so 28.679 by 12.274 minus 4.47 by 5.566. So VP.VQ is 327.126. Now, all that tells us is that it's a big number. It doesn't tell us anything about what the angle is, because the angle totally depends on and I'll copy this formula down. The angle totally depends on what the modulus of the two vectors are. So that's what we got to figure out first. And it's what I would do, is I would get your VP the modulus of that vector is equal to the square root of the I part plus the square root of the square of the I plus the square of the j, so it's 28.679 squared plus minus 4.47 squared. So this is just your distance between 2 points, or Pythagoras or whatever. So I'm not going to go into too much detail. It's the modulus of the vector is the hypotenuse, the length of the hypotenuse of that thing. So it's just c squared equals a squared plus b squared. So 28.679 squared plus 4.47 squared, and we're going to square root that, and that gives us 29.025, which I feel like I'm happy with, because we're going to get up to 327. So I think it's okay that we're at 29 at the moment, because 29 by 20-ish is going to be 327, which is roughly what we want. Vec bar, and that's square root again, and just writing down the thing is 12.274, plus 5.566 squared. Plus, sorry, I'm not deciding not to play ball again. Plus, where are we? Plus 5.566. And get that answer there is 12.274 squared plus 5.566 squared, and square root that gives us 13.477. 13.477. Cool. Now, in terms of our dot product, for this new formula we have, actually I've just gone off and I've just gone on and done part 5 without even explaining it. So right, I'm going to stop there for a second. So calculate the dot product, that's part 4 done. And now, why was I doing that? Well, I knew what part 5 was going to be. Calculate the acute angle. Now, it says acute angle, which worries me that I've got something wrong. But I suppose there's only one way to find out. And I know exactly what I've done. Oh, no, not necessarily. Okay. I do know what I've done wrong. Definitely made one mistake so far, and I'm just going to leave the mistake there, because I want to kind of talk about what I will get. I know what the mistake is. Feel free to pause and try and find it. It is a very easy mistake to make. So I'm going to go through what I would get in the marking scheme. I know I've made one mistake, and it's, yeah, we'll see. So we have VP.VQ, which is 327.126. But that also equals 29.025 times 13.477 times cos theta, cos of the angle between them. What this means then is that cos theta is 327.126 divided by that 29.025 by 13.477. 29.025 is 391.170, which equals, by 327.126 is 0.83627 or 28. And what that means then is that theta equals cos inverse of 0.83628. Again, I know this is wrong because I spotted the mistake I've made, but I just want to play through as if I hadn't. And so its cos inverse of that is 33.251 degrees. So I may have made another mistake, but we'll see. So what I've spotted here is there's definitely, I know I've got something wrong, but it doesn't look like I've got anything wrong right now, because I do have I have an acute angle. I do have an angle less than 90 degrees. I think the word acute is put in there to help people spot a mistake they may have made. So we're just going to go through the marking scheme now. I'm going to kind of mark the marks I get as I go, and we're going to see at what points did the mistake happen. Now, where are we? Is it question 8? Yes, okay, cool. Okay, so question 8. So in total this was 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Cool, 50 in total. So what you say is, so you got 5 marks for stating that they are in the same position, or sorry. So I suppose put it this way: you get 5 marks for saying the SYs are the same, and 5 marks for writing down this equation. And 5 marks for getting that right. So that's 15 out of 50 for that first part. Remembering we only need 5 more to get the 20. And this calculate D was 5 marks for that, and I got 1058, they got 1057. That's just a calculator rounding, so that's going to be fine. Then in terms of I and J, so we calculate VP and VQ. So VP is 28.68, 44. So I got 5 marks for that. And here's the mistake. I hope some of you spotted it, but the mistake I made here was that, and it's something I flagged earlier, is that when we were calculating the distance between the points, the D, when we're doing this and this arrow, we can ignore the direction, the horizontal direction Q was going, because we wanted to add up the 2 things to get D. And I forgot then that when we were turning everything into I's and J's, we need to put everything back in the right direction it's going. So I forgot to put a minus here in front of the I. So I got the J thing perfect, but I forgot to put the minus in front of the I there. So I reckon that's a blunder, because it's a conceptual error. So I think I'm only getting 2 for that one. So I've lost 3 marks for that mistake. Now, what happens now though is my answers for 4 and 5 have to be based on the answer I got for 3. So by writing the dot product formula out here, I get 5. And for writing this here, I get 5. Even though it is completely wrong, I absolutely get a I cannot get docked marks again because it's one mistake I made earlier, and this mistake, or this answer, is correct if my answer was correct. And then you get 5 marks for writing this down, and get 5 marks for getting the answer. So I made one mistake. It was a conceptual error. It was quite, it was a big thing because it was the whole direction something's going, which made the second part of 3 was wrong, the second part of then part 4 was wrong, and part 5. But it was all based on one mistake, so I can't get docked for it twice. So even though I got this wrong, and I may not have even got an acute angle, like an angle less than 90 degrees, but whatever answer I would have got has to be taken as correct. So I'm getting 47 out of 50, despite the fact that I got it wrong. Now, I'm not going to do the correct version, except to say that it needs to be minus 12.274i plus 5.566j. And if you do that correctly, your answer is you're going to get theta equals 164.44, and then the acute version of that is that minus 180 is the 15.56, because if you remember from my diagram, I had this and this, and I had theta as being that angle there, which does look like the 164. So if you want to find the acute version of that, so it's here. This is your 15.56. So if you get to use the correct numbers and put stuff in, you should get 164.44, and then that gives you 15.56 degrees. But again, I made one mistake, got everything else completely wrong because of that one mistake, but I only get docked once. At worst, I'm getting nothing for that VQ. I can't imagine you get nothing because it is just a single blunder. So at worst, 45 out of 50, which is, as we all should hopefully know, is 90%, which I think is pretty good for a question you make a mistake in. So please let me know if there's anything I can explain again or make clearer. Hopefully that was useful for you. Where are we at? Good luck, and I'll talk to you soon.